Okay,
Every type of school I did.
I think we're ready. All right, Unit 7, Lesson 3. Did you notice something missing? You guys notice something missing?
Okay.
Lesson 2 is missing. And Lesson 2 is not going to be tested, so we're going to learn Lesson 2 after the test.
What?
All right? We cut it out because we needed to cut something in order to get to your quiz before break. Learning target 1. Okay. Define a logarithm and then write and evaluate a logarithmic expressions. So, when you have an exponential form, b to the c equals a, it can be rewritten as a logarithm. Notice the logarithm has a base. The base of the logarithm is the same as the base of the exponential. The exponent from the exponential is the answer to the logarithm. So, this helps you know that the logarithm is really just an exponent. The exponent from the exponential is the logarithm. We use logarithms to solve exponential equations. You can rewrite an equation as a logarithm, and this is kind of showing you what goes where. Can somebody let her in? So the base of the exponential becomes the base of the logarithm. Good morning. And then the exponent becomes the answer. And then the answer to the exponential goes here. Ahmed brings up a really good point. The log on the calculator doesn't have a place to put your base. And that's kind of skipping ahead for a moment, but the log on your calculator, when it doesn't say the base, is log base 10. But we don't always want log base 10. So Osman says you're going to go to which button? Go to math. And then when you go down, you scroll down, you'll see something called log base. And then that will be your log base. However, you don't need that yet. Because right now we're just translating. You know, like you would do in a foreign language class, right? You would translate a word from one language to another. We're translating between exponential and logarithm. So I'm going to do one of these for you. And then you guys are going to do the rest, okay? Here we go. First, you write the word log. Then you write the base of the log. The base of the log is the same as the base of the exponential. Next comes the answer to the exponential in parentheses. And then finally, the exponent. All right? What this is saying, if I didn't have the answer over here, it would be saying 6 to what exponent gives you 36? Right? 6 to what exponent gives you 36, and the answer is 2. All right? Rewrite each of these on this side as logarithms. Rewrite these as exponentials. The calculator has nothing to do it because we're not solving anything, we're just translating. Okay. So, log, then the base, then the answer equals the exponent. Log, then the base, then the answer equals the exponent. Now this is one we could put in our calculator. Do you want to try it just for practice? Because it doesn't tell us what the answer is, right? All right. I'm on a different computer, so it doesn't have my calculator on it, but just like Osman told you, you can go to your math button here, and then you'll scroll down to log base. I think it's choice A. Is that right? Is it choice A?
I got 4.
Yeah, that's 4's the right answer. All right, so you'll go to the math button, you'll scroll down to log base, and then you'll be able to put in the 3 and the 81. And you do get x equals 4. All right. On this side, we're just translating to the exponential equations. So notice the base of the log is the base of the exponential. The answer to the log is the exponent, and that is going to equal the 32. And when you write it, it should make sense. 2 to the 5 does equal 32, so that's a clue we're on the right track. Okay, the base, the exponent, and then equals 1. And that's from your warm-up. Remember that one? Finally, the base, the exponent, and then equals 3. On your calculator, there are 2 buttons for logarithms. One of them you know because it says log, right? The one that says log is log base 10. If it doesn't say the base, it's log base 10. So it's just written log. Without a base. Okay? And so that means log x means log base 10 of x.
So hungry.
Okay, the other one is the natural log. The natural log is log base e, and this one's a little trickier because it's not written as the word log. It's ln. ln means natural log, and it's log base e. You guys, if you were here the last time we had class, we used that button for e on the calculator. Remember, we used it for finding continuously compounded interest. Put it away in your bag. And so ln means natural log. Which is log base e. So if you see ln x, it means log base e of x. All right. The first thing I might do when I'm writing this is I might just try to do it the same way I had been doing it. So I would write, okay, log base 10 of 1,000 equals 3. But then we don't write log base 10. Because when it's log base 10, it's just log. Plain log means log base 10. So then we're going to just rewrite it as log 1,000 equals 3. And you can try that on your calculator. Remember the button on the left that says log, you can type in log 1,000 and you should get out 3. All right. I'm going to do this problem here by first rewriting ln as log base e, and then I'll write it as an exponential. So ln means log base e. Okay? ln means log base e. So now that I have it written as log base e, now I can rewrite it as an exponential. The base is e, the exponent is 0, and the answer is 1. You did. I'm going to do this one first. So, I saw a student write this as log base e. That's a good first step. All right, so I'm going to start by writing it as log base e. And then comes root e. And then comes 1/2. However, we never write log base e. Instead of log base e, we write what? ln. Good. So log base e becomes ln, and I still have root e, and I still have equals 1/2. It's not ln base e. We don't write ln base e because ln means log base e. So then you would be saying the base twice. So you just write ln root e equals 1/2. Okay, this one, it can be helpful to write in the imaginary 10 there. It's not really imaginary, it's just invisible. Okay, so when you just write the word log, it means log base 10. So now we know when we write the exponential, 10 is the base, negative 2 is the exponent, and it equals 1 over 100. It's kind of nice that your calculator has that log base on it. When I was growing up, calculators only had log and ln. And so the way that we had to solve problems was a little bit more convoluted than how you can solve problems because we only had those as our tools, just log and ln. You guys have that log base as a tool now. All right. So in this part, we're going to try to solve these without the calculator. Okay? These questions are just like your warm-up questions. The questions are asking 8 to what exponent gives you 8? I'm going to write the words here. So 8 to what exponent makes 8? The answer is 1, 8 to the 1. So log base 8 of 8 equals 1. For number C, I kind of skipped B. For C, what base is that? Log base what? 10, good. So then the question is 10 to what exponent makes 100? Okay, I heard some answers. Can you guys agree? What's the answer? 2, good. So the answer is 2. So I want you to try these others without the calculator. All right, guys, 2 to what exponent gives you 16? 4, good. All right, next one. You might want to rewrite it as log base e of e because that might help you think of the answer. Log base e of e. All right, e to what exponent gives you e? 1, right.
Last one's -2. Oh, get out of my face.
All right, Ahmed suggests this one is -2. 5 to the -2. Does that make 1 over 25?
Yes, sir.
All right, if we're not sure, we could use the calculator to check it. So press math. Go all the way down to log base. If you can't find it, ask your neighbor to help you find it. And then type in log base 5 of 1 over 25 and see if you get -2, if we can confirm Ahmed's answer. Anybody get -2? Okay, good. Okay, and then 3 to what exponent gives you 1/3? It is -1. Okay. Logarithms are defined as the inverse to exponentiation. Remember that inverse functions undo each other. So, when you have a base of your logarithm matching a base of your exponential, they undo each other and just give you 2. The same thing happens if you have an exponential and your exponent is a logarithm with the same base. They would cancel out and give you x. Okay. I want you to go through and see if you can find ones where the base and the base of the exponential and the base of the logarithm are the same, so they'll cancel and give you a simple answer. You can skip around to find the ones that'll be easiest. All right, here we go. 5 to what exponent gives you 25? What'd you get? Jessica got 2. Anybody else get 2? So 5 to what exponent gives you 25? So 5 to the 1 is 5, right? 5 to the 2 is 25. So trying whole numbers is actually a good thing to do, but you also could use your calculator, right? Oh, sorry. So that nothing canceled out there, right? We can actually solve this. You can turn this problem into one where something cancels. Please close your computer. Because 25 is 5 squared. So you could rewrite this as log base 5 squared, like that. And then these can cancel. And then you get 2. But the other way to do it is just think 5 to what exponent gives you 25. In this one, you canceled these, and your answer was just what? -2, right? All right, ln means log base what? ln means log base e, thank you. And so when I have log base e to the 2, those will cancel, and I just get 2. This one's a little bit tricky. We need to rewrite the cube root of e as an exponent. ln e to the exponent. Do you guys remember what exponent that would be? It's a fraction.
1/3.
It is 1/3. Remember right here, this has a 1, right? So it'd be 1 over 3. All right, so ln e to the 1/3. Then the ln e can cancel, and we just get 1/3 as your answer. All right, so because ln means log base e, anytime you have ln e or anytime you have e to the ln, they will cancel and just give you what's remaining. ln e cancels, we get 5x. All right, for I have seen two different answers in here. I've seen the answer 0 and the answer 1. Does anybody want to raise their hand to defend their answer being either 0 or 1? I see one hand so far, but I would hope to see a few more. 2 people are ready to defend their answer of 0 or 1? 3 people? All right, Shahir, what were you thinking? Why? Say it again. 1 times 14 gives you 14. This is true, but remember it's related to an exponent. Can you make an exponential equation? 14 to the equals 14. Who agrees with that explanation? Does that make sense? All right, very good. If you wanted to, you could put a 1 on the 14, right? Because we know 14 to the 1 is the same as 14, like that. And then when you cancel out the log and the 14, you can see you're just left with that 1 there. This is right. All right, Nahar, when it doesn't say the base, when it just says log, it's log base what?
10.
Say it again? Yes. When it just says log and it doesn't say a base, it's log base what? 10. It is log base 10. And so this is log base 10, and the base of the exponential is also 10. So this cancels, and we just have 4. Let's do this one last. Let's do this one next. This is also log base 10, and so it's going to cancel with this 10 and give you 3. I want you to think for a moment about how could we use a strategy similar to what we used in B to answer K. All right, so let's do what Crystal suggested. Let's rewrite the 1 over 100 as 10 to the negative 2.
Isn't it just negative 2?
That's going to be our final answer, yeah. And then this logarithm that doesn't have a base, we know that means log base 10. So now we can cancel and get the answer, negative 2.
Is it always this easy?
So there's a lot of different aspects to logarithms. We have I think we have 2 more lessons to learn before your quiz. All right, let's look at example 5. In example 5, we're going to use logarithms to solve exponential equations. So here, you have an exponential equation. Just like on your warm-up, you could probably guess and check your way to an answer, but it's more efficient to do it with a logarithm. We want the base of 3 to cancel, so we're going to do a log base 3. So I'm going to write log base 3 of 3 to the x and log base 3 of 531,441. The reason I chose to do log base 3 on both sides is because that will cancel out my base of 3. So now x is by itself on this side. On the right side, I can use my calculator to get an answer out of that. So on your calculator, I'm really sorry I can't show you too much today. Oops. Okay, so one more time, you press math, you scroll down to log base, and then you pressed enter, and then you typed in log base 3, 531441, and we get 12. Let's do C. I'm going to do log base 1 over 100. Your base can be a fraction. That is not a problem. Log base 1 over 100. 1 over 100. to the x, and then log base 1 over 100 of 1,000.
Why is it base 1 over 100?
Because that's the base of the exponential. So whatever is the base of your exponential, that becomes the base of your log. That will cancel out. And now on your calculator, you're going to type log base 1 over 100 of 1,000. Negative 1.5. All right, so I want you to do B. You should get a nice, easy answer, like with a decimal that doesn't go on forever. When you do D, we're going to get a number close to what we got in our warm-up, but we'll get a few more decimal places of it, okay? So go ahead and do B and D. Okay, let's quiet down. Log base 4 to the x equals log base 4, 128. Okay, what did you get? 2.5? 3.5? Anybody confirm 3.5? Okay. All right, last one of these. We're going to do log base 2 to the x, log base 2, 5. Raise your hand if you can read me all the decimal places that the calculator gives us. Shahir? Wait, guys, I can't hear. 3, 2. 0.95. Can you check? Did I write them down right? Okay, so again, this is still rounded because your calculator is rounding an irrational number. But your calculator did give you a lot more decimal places than you would have the patience for guessing and checking, right? So this was very helpful to get the most accurate answer possible. All right. This one says rewrite or simplify each logarithmic function. So a problem like this one has everything in it. We're going to rewrite it. A problem like this one has an x. So after rewriting, we'll be able to solve. Let me do this one to start. The base of the logarithm is 2. The answer to the log is the exponent. And that equals x. All right, and then you could use your calculator to evaluate 2 to the 6. 2 times 2 times 2 times 2 times 2 times 2. What do you get? 64. All right. I want you guys to do the other 3, please.
Calculator? Yeah. Calculator. I can tell the calculator. What's on your right left?
Ahmed, you answer them?
Yeah, that's why you're worried about me. Wait, the other 3 fall?
Yeah.
Look at my, is this right? Is this right? Yeah. Wait, you gotta use math. I don't like that. Math button. Stop writing shit on the paper. That shit why you're not? Why you're not? Stop! He's supposed to do on the paper. No.
You know who needs
What were you going to write?
All right, guys, let's see how it goes. 14 to the negative 2 So there's nothing to solve there, right? There's no x. Let's try the next one. Log base 8 of a equals b. Now this one has two variables and it's just one equation, so there's actually multiple things a and b could be, so we don't need to solve that one. But this last one has only one variable, so we'll be able to solve it. So log base 5, 125 equals x. Do we need a calculator for that? A calculator is a good tool, but we don't need it, right? Because the question is 5 to what exponent gives you 125? All right, so think about it. 5 times 5 is 25, right? So that's 5 to the 2. And then times 5 again would be what? 125. Yeah, so it's just 3. So x equals 3. But you could confirm it on your calculator.